Hello, Math A Honors students. This is Mrs. Stengel again, and I'm going to be covering 7.1c lesson, Perimeter and Area of Irregular Shapes and Expressions. I've already started a little bit on number 1, so I'm going to review that again. I'm getting used to technology. It paused me and I had to restart the video, so I'm going to pick up where I left off. Hopefully you have something to write with, you have your printed copies of the lesson, or you're using a lined piece of paper or a PDF. So let's start again. We're going to be finding the area and perimeter of the following shapes. Write any expressions to show how you arrived at your answer. Be sure your final answer is simplified, like terms are combined, and has the proper units. So on number 1, I already began showing my work. And as you can recall from the 7.1b lesson, one method we can use to find the area of an irregular shape is by finding the area of the big shape minus the area of the little shape. So the area of the big shape in this case is a 60 by 100 foot rectangle. So I'm multiplying 60 by 100, where you see I get the 6,000. And then I'm going to deduct that from the smaller area of the rectangle, that's 14 by 45, which is where I got the 630 from. One of the missing measurements that I had to find was the length of 14. And the way I found this is by looking at the entire length of this as 60, I subtracted it from 12 plus 34, which is a total of 46. And that's how I got the 14 for that missing measurement right there. So I have 6,000 minus 630 is 5,370 feet squared. So now that we're all caught up, let's find the perimeter. So we're going to find the perimeter of this irregular shape. And again, perimeter is adding up all of the border of our shape, all the outside border. So I'm going to start with the bottom, which is 100, and just work my way around the shape. So I have 100 plus 34 plus 45 plus 14 plus 45 plus 12 plus 100 plus 60. Adding up all of those amounts gives me 410 feet. So perimeter, we use feet, and area, we use square feet units. All right, taking a look at number 2. It's the exact same irregular shape, except we're missing some sides. Instead of given 45 feet for this length right here, we're given X amount of feet. So that means that this length is also going to be X feet. We can still use the same information from the original rectangle to note that this is 14. Okay, so we're going to find the area by doing the same formula. We're going to find the area of the big minus the area of the little. So the big shape is still 60 by 100 feet, but the little rectangle is now 14 by X feet. So we're going to put this formula in simplest form. We're going to multiply 60 times 100, and we're going to get 6,000. And we're going to multiply 14 times x, and we're just going to leave it as 14x. So in order to label our final answer with square units, I would like you to use the distributive property and put parentheses around your answer and put feet squared after both expressions. Okay, let's find the perimeter. So perimeter, same thing. We're going to add up all of our units around our border. So we have 100 at the bottom, 34, x, 14, x, 12, 100. I'm going to put that up there so it matches it, and 60. Okay, so we are going to make sure that we look for like terms and we combine those together. So I notice that I have an x and an x, which are considered like terms. So I'm going to add those two quantities together and get 2 x's. And if I add all my numbers together, I get 320. So in order to complete my answer, I need to add feet. Units are very important. Okay, moving on to number 3. We first have to look at our irregular shape and see if there's any missing measurements that need to be added to our figure. So I notice I have 2 missing measurements. I have one missing measurement at the bottom and one on the side. So to get the missing measurement for the side, I'm going to look at my total distance, which is 9/7. and I'm going to subtract 3/5. In order to subtract fractions, you have to find common denominators. So I'm going to change these to a 45 over 35 and 21 over 35. 7 times 5 is 35. That was the easiest way to find a common denominator. So this new length is going to be equal to 24 35ths. All right, so I'm going to write it in the figure, 24 35ths is my missing length up there. Another missing length is down at the bottom. So in order to find this missing length, I'm going to do the work over here. I'm going to take 7/8 and I'm going to subtract the distance of 1/3. Again, easiest way to find a common denominator is to do 8 times 3. So I'm going to change these fractions to 21 24ths and 8 24ths, which is 13 24ths. So I'm going to replace this length with 13 24ths. Okay, now that I have the missing measurements, I'm going to start by finding the area. So the area of this figure, I'm going to do the area of the big minus the area of the little. So the area of the big rectangle, if I surrounded this entire figure, would be 9/7 times 7/8. And the area of the small rectangle, you can see this right here, would be 3/5 times 1/3. All right, now I'm going to cross cancel any common factors. So I'm going to get 9/8 minus 1/5. Okay, again, in order to subtract fractions, you need to find a common denominator. So I'm going to change these to 45 40ths, minus 8 40ths, which simplifies to 37 40ths. And to complete our answer, we need yards squared. Put a box around this. So we have 37 over 40 yards squared for the area. Now let's do perimeter. So for perimeter, we need to add up all of the outside border. So I'm going to start with 13 over 24, 3/5, 1/3, 24 35ths, 7/8, and 9/7. Holy fractions! So we need to look and see if there's any fractions that maybe have some commonalities with their denominators. So if I were to take a look at this denominator 24, I'm looking at all these other denominators to see if maybe there's one denominator that can go into 24. So I'm going to use the 13 24ths. I'm going to use the 1/3. I'm also going to use the 7/8 because I notice that all three of those could have a common denominator of 24. So I'm going to start with those three. We're running out of room here. So we have 13 24ths. I'm going to change 1/3 to 8 24ths. And I'm going to change 7/8 to 21 over 24. All right, so just adding those three together, I get 42 over 24, which is 7/4. All right, now I'm going to go back and look at the denominators that have 5 in something that has a commonality between 35. For instance, 5 times 7 is 35. So I'm going to add those together. So I have 21 over 35 plus 24 over 35 plus 45 over 35. All of those added together is 90 over 35, which is 18 over 7. Okay, now I have 7 over 4 and 18 over 7, which is still getting closer to my answer. In order to find the final answer for perimeter, I need to add together the 7/4 and the 18 over 7. So a common denominator between 4 and 7 is 28. So I'm going to turn this into 49 over 28 plus 72 over 28, giving me my final answer of 121 over 28 yards. Wow, I barely fit that all on one page. Where's these scientific calculators when you need them? All right, let's look at problem number 4. Same problem, except we're given that this length is x. So for the area of this figure, we're going to use the fact that this is x instead of 9/7 and subtract 3/5 from here. So for the area of the larger rectangle, we're still going to do the area of the big minus the area of the little. The area of the big rectangle is going to be 7/8 times x, and the area of the smaller triangle is still going to be 3/5 times 1/3. Okay, so we're just going to actually leave our answer after we cross cancel as 7/8 x minus 1/5. I'll put parentheses around that so I can put my units for both. So it'll be yards squared. So this one was area. Do you think I can fit perimeter in that spot right there? Probably. Okay, challenge accepted. So for the perimeter, if not, there's always room on the back, right? For the perimeter, we are going to add up all of our lengths again. This length is still 13 over 24. So I have 13 over 24 plus 3/5 plus 1/3 plus x minus 3/5 plus 7/8 plus x. Well, the nice thing about this is the 3/5 will cancel because one's negative and one is positive. And I've actually already added up together the 13/24, the 1/3, and the 7/8 from a previous problem. All of that added up together gave us 7/4. So I have that the perimeter is equal to 7/4 plus I have an x here and an x here. So I'm just going to write 2x. To complete our answer, we need parentheses and we need to put yards after we're done. I fit it. I knew I could do it. I hope that you guys can do it too. Okay, we're moving on to number 5, which is on the next page. So please feel free to pause your video if you need to write down a lot of this work. Thank you guys for doing all this. All right, looking at number 5, we have to write an expression to represent the indicated values for each of the following irregular shapes. We're going to be finding the area and perimeter of the figure below. So we're going to be doing 2 things per problem. All right, so let's start with the area formula. Remember, the best way to do this is to find the area of the big minus the area of the little. So for the area of the big rectangle, we have 7x and 14 for our dimensions. And for the smaller rectangle, let's see what we have here. Okay, so we need to take 14 minus 5 to get this right here is 9. So we're going to need 3x times 9. So we have 7x times 14, that's 98x. And we're going to subtract 27x. Now, since these are both like terms, 98 minus 27 is 71x. And then since we don't have units on this problem, I'm just going to write units squared. If they were giving us units, I would write feet or centimeters squared. Okay, now let's find the perimeter. So the perimeter, we're going to add up all of the border, starting with the bottom, 14. I'm missing a measurement right here on the side. This length is 7x and 3x. So 7x minus 3x is equal to 4x. So I'm going to add 4x around my border, plus 9 plus 3x plus 5 plus 7x. I'm going to look for all my like terms. So I have a 4x, 3x, and a 7x. Those can be all combined together. That'll give me 14x. And then I can add 14, 9, and 5, and that will give me 28. I'm going to leave my answer like that, and I'm going to put units afterwards because I don't know what the units are. If the area is 781 square feet, what is the value of x? So I'm going to go back to my answer as I drop my pen, sorry about that. And I'm going to write down my answer is 781, and I'm going to plug it into this formula for area, which was 71x. To solve for x, I'm going to divide both sides by 71, and I get x is equal to 11 feet. All right, moving on to number 6. It says find the area and perimeter of the trapezoid below. So recalling the area of a trapezoid, we have 1/2 base 1 plus base 2, and we're going to multiply that by the height. So our bases always run parallel to each other. So D is considered one of our bases. We'll call it base 1. And D plus 6 is also one of our bases. We'll call it base 2. Our height always runs perpendicular to the base. So 12 would be our height in this case. So let's plug it right into the formula. We have 1/2 base D plus base 2, D plus 6. And we're going to times it by the height of our trapezoid, which is 12. Okay, we can take 1/2 of 12, which is 6. So I'm going to replace this with 6 times. I'm going to combine my D's together. So 2D plus 6. And if you want to, you can distribute the 6 over the parentheses. So you finally get 12D plus 36. And I'm going to write this as units squared. This was our area. Okay, so next for our perimeter, we're just going to add up the border all around. So we can start with the base, D, plus 6, plus 14, plus another D, and plus 12. Again, we're looking for anything that has like terms. So we're going to add our D's together and get 2D plus 32. We combine our numbers, and I'm just going to write units after on my answer. Okay, moving on to number 7. We have to find the area and perimeter of the figure below. So for area, I'm going to use that formula for method 1, which is the area of the big minus the area of the little. So I'm going to look to see if I need any missing measurements for this. This is 7. I do have an unknown right here, but I have a 5x here and a 3x here and a total of 15. So 15x minus 8x is 7x. So that would be the unknown length right there. Okay, so I have a big rectangle that is 15x by 7. And I'm going to take away a little rectangle that is 5 by 7x. 15x times 7 is 105x, and I'm going to take away 35x. And that will give me a total of 70x. And I'm just going to write units squared since we don't know the units again. Okay, for perimeter, let's see, let me write this in a different color. For perimeter, we're going to add up all of the measurements, and then we're going to plug in x equals 2.5 for the perimeter. So first, let me find the perimeter. The perimeter is 5x plus 5 plus 7x plus, I'm going to add another 5 here, 5 plus 3x plus 7, keep going, plus 15x plus 7. Okay, now I'm going to combine all my like terms. So I've got a 5, a 7x, a 3x, and a 15x. If I were to combine all that, I would get 30x, and then all my numbers combined would give me 24. Oops. Again, this is in units. All right, so now it's saying if x is equal to 2.5, what would be the perimeter? So I'm going to take my value of x and plug in 2.5. So I'm going to multiply. Oops, for a second.